Okay, so let's take a look at the review sheet, just in case you want that little bit extra help. So here we go. A consumer organization estimates that 28% of these cars have some kind of cosmetic defect. 7% have a functional defect. So whether it's a scratch or something that's actually wrong that doesn't cause a car to work properly. And then 2% have both. There's a keyword both. That leads me to believe maybe our best bet here is probably just to draw a quick table for all of this information. So here we go. This would be cosmetic. This would be a functional defect. And it's yes, no, yes, no, and again, at the end of each of those, it's total. So 28% of cars have a cosmetic defect, which means that 72% of cars don't have a cosmetic defect. 7% have a functional defect, which means that 93% do not. 2% of cars are yes and yes. Fill in the gaps now. So take a quick second, and then this would be 67. All right, so once we have our table, we should be good to go. So part A, if you buy a new car, what's the probability that it does have a defect? All right, so probability has some type of defect. It could have any of those defects. So it could be cosmetic, it could be functional, could be both. This is just a matter of using my addition rule, so that'd be cosmetic or functional. And remember, that means that you do probability of A plus a probability of B minus the overlap. So that would be this total would be 33.33. Probability that has a cosmetic defect but no functional defect. So this is, I'd just go straight to the chart. Go to yes cosmetic, no to functional, and that would be 0.26. Sitting right there in the chart. Part C. If you notice a dent, what's the probability that it has a functional defect? So this is a conditional probability. This would be the probability given that we know that it has a cosmetic, right? A dent was a cosmetic. Given that it has cosmetic, what's the probability that it also has a functional defect? So that would be the probability of both, right? Functional and cosmetic over the probability of cosmetic. And so functional and cosmetic, right? There were 2% of cars that had that. And out of the 28%, which are cosmetic, 0.02 divided by 0.28 equals, let me give myself a little bit more room. So that'd be 0.071. All right. Part D, are they two things disjoint? And that is no, because there's an overlap. Because 2%, right? It was 2% have both problems. Have both problems, or another way to look at that, there's an overlap. All right. And then finally, are the two kinds of defects independent? And recall that independence, the probability of A given B would have to be equal to the probability of A. That's independence. Well, up here in part C, we've already done a conditional probability. So why don't we take advantage of the work we've already done? Does the probability of functional, kind of down here at the bottom of the screen, let me move down just a little bit, give myself a little bit more room. So does the probability of functional given some kind of cosmetic issue, does that equal the probability of a functional issue? So as we saw before in part C, this probability is 0.071, and then the probability that we get a functional defect is 0.07, and although these are very, very close, they're still not equal, which means these two things are not independent. All right, so we move on to number 2. This table, this is a table where you can start pulling all sorts of stuff in terms of the overlaps and whatnot. So just a matter of reading the table. So what's the probability that we select someone at random that has earned a bachelor's degree? So bachelor's degree, just go right to that part of the table, and there are 1399 out of the 2671. Feel free to turn that into a decimal if you'd like. I'm just going to keep moving. Earned a bachelor's degree. So the probability that they've earned a bachelor's given that they are female, right? So that's probability of bachelor and female over the probability of female, and that would be bachelor's and female would be 804 um, out of um, the probability of a female, 1561. All right. Part C. Earned a bachelor's degree given that they are not a female. Well, that'd be the probability of a bachelor's given that they are, the other option, a male. And for this one, the males that earned a bachelor degree would be right there. So out of the males, right, out of the males, there are 595 that did not, that did earn a bachelor's degree. All right, part D. See if I can keep myself in here so I have enough room. Probability they earned bachelor or an associate's. So bachelor or associate. Just so we see it one more time, this is equal to the probability of bachelor plus the probability of associates minus the overlap. Here, you can't have an overlap between bachelors and associates. So in terms of the numbers, um, the probability that we get bachelors, uh, that's 1399 out of the 2761. The probability someone gets an associate's 665 over 2671, and just there is no overlap here, so it's not really going to affect what we're doing. But 1399 plus 665, this will end up being 2064 out of 2671. And for those of you that really like to put things in terms of decimals, here you go, 0.77. So about 77% of the people earned one or the other. Okay, so part E, earned a doctorate given that they are males. Probability of a doctorate given that they are a male. So again, we don't necessarily have to do the conditional formula because the table sets up so nicely for us right here that we know there are 1,110 males and there are 25 doctorates out of that group. F, earned a master's degree or is a female. Here we go all of a sudden where we could run ourselves into a situation where there is an overlap because female and masters do in fact overlap just a little bit. So again, so the probability masters or female, and so that'll be masters plus female, probability of masters plus the probability of female. Because there's a group now we're going to see an overlap. We need to take that overlap out. Oh, excuse me. Put the wrong symbol in there. It's minus. So the probability that someone has a master's, that's 559. So 559 plus female 1561 1761. And then we're going to take out the overlap because we've counted this group of females twice, so minus 320. Nope, excuse me, sort of the wrong one. Oh, no, that's correct. So I want to take that back out, 329. So take that group back out. I'll take the 329 back out. That's all over 2761. 2761. So 559 plus 1561 minus 329. So 1791 out of 2761. And again, for those of you, I know I'm switching kind of back and forth, but if interested, this is 0.649. So about 65% of the folks are either female or have a master's. Earned an associate's degree and is male. I wouldn't remember. We don't know if these things are independent. We have not done an independence check, so multiplication rule doesn't work. So what I suggest here, just go to associates male. That'd be that number right there. So it's 260 out of the total. 260 out of 2661. I'll slide down here where I can get some room. So for part G, again, 260 out of the total. Don't use multiplication rule here. So that was male and associates. Just straight to the table. 260 out of the 2671. 260 out of the 2761. There's that one. And then finally for part F, is a female given that they've earned a bachelor's degree. So this was female given a bachelor's degree. So just so we can see that female and bachelor's over the probability that they get a bachelor's degree. So female and bachelor's, female and bachelor's is 804. This would be equal to 804 over the probability that someone gets a bachelor's degree. The bachelor's degree was 1399 out of the 1399. And I'm not even putting the denominators in here either because as we saw in class one day, those will all just cancel out.